Okay, just had to make sure the mute button went off there. Hey everyone, how's it going? And welcome to PROCEPTION Livestream. I'm Robert Wolf, Hackster Pro, ARM Ambassador, and your host for the next hour. First off, I'd like to thank y'all for joining us. Whether you're tuning in live or catching us on a replay, it's great that you're here. Today's live stream is brought to you by the folks at Hackster and Avnet, and we will be shining the spotlight on Tria Technologies, a global leader in embedded computing design and manufacturing. We've got an incredible session lined up for you. Together with my co-host, Tory Moghadam, we'll let y'all be bringing on in just a moment, and our special guests, Monica Houston, who manages an AI ML team at Tria, and Mario Bergeron, who is a Tria machine learning specialist. We'll be diving into Tria's journey from product to concept and market-ready innovation. So before we go in there, I think I should just give you a little bit of a preview of what we're going to kind of go over today. So first off, of course, we'll get to know our guests and we'll get to know Tria Technologies, followed by a quick lesson on MediaPipe. Now, if you don't know what MediaPipe is, that's okay. I don't either. We're going to learn together. Then we'll dive into a world of open source integrations and cutting edge hardware with Tria Technologies at the heart of it all. Next, you'll get an inside look at some very cool projects that showcase sign language detection, pose estimation, fitness, and all of these projects that we're going to talk about today are already available and featured on Hackster.io. So, of course, we'll share the links to those as we get to those segments. And if you're watching this on demand, make sure you check out the description below. The links will be there for you to go check them out. Finally, we'll discuss Tria's efforts to empower developers through open source tools like LibCamera, V4L2, GStreamer, and ROS2. All driving innovation in robotics, multimedia processing, and so much more. So I would say, while we get this spun up, go grab your coffee, get comfortable, and get ready for some fun. We want to share, what our PROCEPTION looks like. And if you have, I'm trying to make a slogan here, right? But share your PROCEPTIONs with us, if that makes any sense. Drop your questions in the chat, and we'll get to them as soon as we can in between, the questions that we have for our guests. If you enjoy this content, make sure you smash the like button. Of course, subscribe to the DevEco YouTube channel. And we look forward to bringing you more content like this as we progress in these live streams and other cool stuff that we'll be doing in this channel. Now, Tory, I got you in the green room, but I'm going to bring you up in here. Boom. Over to you. How's it going? Are you excited?
Yes, I'm excited, Robert. Thanks for that wonderful introduction. I'm excited specifically because I love the embedded space, and also machine learning and artificial intelligence is one of my passions. So I'm excited to hear from our guest today, and I think we should just hop right into it. What do you think?
I think that's a good idea. So let's get to know our guests. I think we're going to bring them on right now. Let's start with Monica Houston and Mario Bergeron. I hope, Mario, I'm saying your last name correctly.
Yeah, that's fine. It's a French name, so it's Bergeron, but Bergeron is fine too.
You gotta be a little easier on us.
I accept both.
Okay, okay. Bergeron, I'll try. So yeah, we like to kind of start these off with what we call the origin stories. So Monica, if you wouldn't mind kind of starting us off with this, letting us know a little bit about who you are and what you do with Tria.
Sure. I was at Hackster previously. So at Hackster, I worked on a number of our developer programs. So we did a webinar or a hackathon tour all across the US and then in Asia as well. We've done Hackster Live, which is now maybe being revived. So I'm really familiar with the Hackster side of things. And then we got acquired into Avnet. And after we joined Avnet, I decided to go back to school for machine learning and do a master's degree at UW. I finished that recently. But since I've been at Avnet, I've been working on machine learning as part of the team that's now actually Tria. Yeah, so we're Tria now.
Very nice. Monica, I feel like you and I might have a live stream together, like when I was doing open hours or innovation coffee at some point. I
think so, yeah.
I'm going to have to dig that up. I'm going to dig that up, and if I do, I'll put it in the description as well, so you can kind of take a trip into the past. But cool. Thank you, Monica. I appreciate you being here. I really do look forward to having this conversation about Tria and all the cool stuff you guys are up to. Mario, you're up next. Can you tell us a little bit about yourself?
Yeah, sure. I guess I've been working for about 30 years. I graduated in 1994. And I mentioned that because that was the second AI winter when AI was not so popular. The AI term that we were hearing everywhere that we're starting to get a little fed up about has been around since 1956, I believe. So quite a long time. And it's been popular, unpopular, popular, unpopular. Now we're really seeing a boom. But at that time, in this second AI winter, I was offered to do my master's degree on an obscure subject called neural networks. And I decided no. I was way too interested in hardware. So I started my career as an ASIC designer in Western Canada. And from there, I moved on to a little higher from ASICs to just DSPs and FPGAs. And from there, the technology evolved to SoCs. So in addition to have these programmable hardware devices, we would have these industry standard processors. So that kind of forced me into Linux land, like getting more involved in software. And in the recent years, well, I've gone to the IML, so I've come full circle back to this neural network that was proposed 30 years back.
30 years in industry.
Yeah.
By the way, I think one of the most awesome times to be in tech and of age, right? Because like 1994, that's like circa Linux kernel coming out. Like that's like circa open source, kind of like just kind of like getting setting its roots, right? I was 9 when you graduated, so I was probably trying to find the next cool Nintendo game to buy. But no, awesome. Thank you very much, Mario. Appreciate your introduction as well as Monica. Thank you. Tory, do you want to touch on anything?
No, I think we had a couple of questions. I'm kind of interested about the origins of Tria, but I think I'm going to bat that over to you. But I have a follow-up question next.
Let's start off. Let's double team this question, right? So let's start off. Maybe one of you. We want the high level view of Tria, right? Let's just start off painting that picture. What is Tria? What do you do? And then maybe we can then go into like the origins of Tria.
Sure. So Tria is. There were a number of companies under Avnet that created compute modules as well as entire systems and HMIs. So we got spun off into our own company that is sold exclusively by Avnet that's called Tria. So we actually create SLMs, baseboards, displays, cooling solutions, other accessories, and help developers to get equipment manufacturers to get up and running by providing our solutions. So we do a number of different standards like OSM, SMART, Q7, COM, and we're the largest global COM manufacturer. So we're helpful to anyone who needs to embed technology in their products.
I actually have the Tria website open here, right? It's not intentional, but the amount of stuff that you guys do is just it's expansive. Like there's so many things to explore on your website. Like I mean, just and as I kind of explored, I have a bunch of questions on this. Tory, before I go into my next one, go ahead, please.
Yeah. So I was kind of curious though, like how Tria became inspired to focus on what you currently are focused on, specifically, if you want to tell us how you got there. I don't know if there's a specific story, but.
From our side, we were doing Avnet boards. So we were doing a bunch of developer kits, and Mario has been working on this you were on this team for a long time, Mario. So you know the history.
13 years, yeah.
Yeah. But we've done developer kits, so kind of selling to smaller customers than Tria now. Tria now sells to larger customers generally. But Mario, do you want to answer based on your?
Well, sure. Like now the team is quite large, but when I joined, it was, I guess, a sub team of what's known today as Tria. We were like pretty focused on Xilinx products, so just the FPGAs, and like the reason of doing that from a distributor point of view, Avnet, was to like anyone doing a design you don't just put an FPGA on a board and you're done. You need memory, you need clocking, you need often when it was an FPGA you needed some kind of processor. So it was creating this attach, like how can we see all these components from different manufacturers and show how they could work together. So that's the value that Avnet brought and our team specifically brought. So I've been pretty much like on the Xilinx side for all that time, for those 13 years. But now the team's gone quite wider than that. So like the other, the processor solutions, NXP, Renesas, Qualcomm, etc. And with the integration to what used to be called Avnet Embedded, they've got this huge expertise on developing boards with these open source industry standards like OSM, SMART, etc. So I guess that's my take on it.
But so
really,
you were at Tria like from the beginning before it was called Tria?
well, yeah, it was Avnet. It was a team
Gotcha.
under Avnet. So there's a lot of
Gotcha.
these.
Oh, so, okay,
There's a
that
lot
makes
of
sense.
like the Hacksterio is an Avnet company. Wutekio is an Avnet company. Now Tria is an Avnet company. So
I love it. I love
yeah.
it. So let you bring up Hackster.io. All right. I'm a Hackster pro, love Hackster. I'm a wandering developer, an independent wandering developer, but I'm also an aspiring entrepreneur and I like to build things. I'm an inventor, maybe like my friend Tory over here. One day I want to come up with something that I'm capable of productizing, right? So what does my journey look like with Tria? This is something I'm trying to kind of discover as a developer. What does it look like with Tria? What are you gonna? When do I go and approach you for help?
You want to give a stab at that, Monica?
Sure. So I guess if once you're ready to manufacture, generally, I guess actually before manufacturing, we can do all kinds. We can do design for manufacturing. So if it's oftentimes hard for you're trying to start a hardware company just to get the silicon for your product and to get it in the quantities that you need can be really difficult. So it's nice that we partner so closely with Avnet because they are also distributor. So we are able to get the silicon. We already have these boards and SLMs that come with a Yocto Linux image as well as possibly other images. So you can start right away using our BSP. We have like firmware for various accessories. So you can get started with that. We also support some open source. Talk about that later, hopefully.
You will.
So lots of support existing already. So you don't have to start from absolute zero and try to, get it's really hard to get samples from a lot of these suppliers if you're just asking for a single sample. So you can start with the board that we have.
On that note, it kind of feels like developers might want to explore Tria, right? And the SLMs you offer, the supply chain that you kind of like are into. Because if you start building on something that's possibly not within your supply chain, then maybe you put yourself. I've seen lots of hardware developers like basically dig themselves into a corner. They start building something and then they realize like that component that they now need a bunch of is end of life, right? And so you guys are tracking that. You guys are making sure that whoever's building whatever it is, like you kind of keep track of that. So if you're kind of heading towards that, yeah, I can imagine that it's a big deal.
Yes.
Well, that's kind of goes into my question is what would you say to developers that are, beginning their journey? Are there some pitfalls to avoid or, what should they reach out to you right away, before they pick the wrong hardware or go down the wrong path? Any tips or tricks that you'd like to express?
Mario?
For people?
I'd say like if you have embedded hardware, if you're creating your own hardware, you may want to plan out what software infrastructure is available for it. Some examples of this are like just cameras or image sensors. You may decide to use an image sensor and find out when you're bringing everything online that no one has done a Linux driver for this. It seems like a little absurd and surprising, but not every image sensor has a Linux driver. I'm assuming that you'll be running Linux on this. If you're in bare metal, then you're doing a lot of hand coding. You'll probably get through it yourself, but that's one thing. So if you don't have the Linux driver expertise, maybe plan ahead, make sure that exists, because that's surprisingly a very big chunk. We actually have like a specialized team that deals with that with Wutekio.
And
but
costly,
it's
Mario, right? Like it's pretty costly. Like I mean, I remember some people like getting paid a lot of money to write like a single driver. And if you're like trying to bring up your product, you're already spending a lot of money on it, having to write that driver as well, or find that expert.
Yeah, and that's just getting your access to your image sensor. The next thing is if you want image quality, well then you're talking about an image processing pipeline, an ISP, and you can either have something that's built into your camera, which will probably save you a lot of headache, or if not, then it has to be in your somewhere in your pipeline, either in your FPGA fabric, if that's the kind of device you have, or directly in the processor. And even there, sometimes you'll have a design with an ISP, but if you don't know how to program it, it's not giving you the quality that you need. So it's like trying to plan out your system and make sure that the software infrastructure is available to you. It's not just a hardware play anymore. It's well, we used to have more time to develop things. Now there's a market pressure to get things up and running like really fast. So, and that's only possible by leveraging all this software infrastructure. And if you're a small company or a startup, I think sometimes the cost to do like proprietary solutions could be fairly expensive. So turning to the open source becomes the most viable solution. So I think on our boards, we're trying to get these things up and running for that specific reason. So our customers can get to their value add, which is the application, not, okay, get the image sensor running, get the drivers running, get the this. They want to concentrate on what makes them unique, which is, well, whatever they do, but they want all this infrastructure ideally to be up and running when they start. So that's kind of where we want to position our development boards.
Yeah, no, this is great. Actually, in fact, you kind of give us a good opportunity to answer a question in the chat from one of our viewers, from Dr. Sanjeev Sarpal. He asks, what about reference designs, right? And you kind of did just talk about, well, I mean, along with reference designs, like, is there anything that Tria offers in this arena?
Well, I think the most valuable reference design, if you want, is what Monica alluded to previously, like a Linux image that's up and running. I think that's, and you could create do various things around this, but that's essentially what I think people are looking for. They may want, okay, show me how to use this peripheral, etc. But essentially, people want like an operating system that's running on the board. I know, like in the last session you guys did, we talked about Windows on ARM. That's I have no expertise on this. I've more been in the Linux land, but that seems like another interesting option to have. But like in that case, in the same as Linux, ideally you want it to be running so you're right away working with it.
Yeah, the software ecosystem is pretty important. Sorry, I didn't mean to interrupt.
Yeah, so I would equate having the operating system running with all the peripherals, the supported peripherals. That's the most valuable reference design. But they can have like flavors. Okay, I want to have a reference design specific to video. I want to have a reference design specific to maybe some preventative maintenance, like more sensors instead of video devices. That'd be kind of, yeah.
Yeah, our out-of-box images have out-of-box demos on them. Oftentimes the same things that we'll show at like trade shows like Embedded World, we'll actually include on our default image as like the out-of-box demo, so you can get started with that right away, and we'll include the source code for it on our GitHub as well.
Awesome. Tory, did you want to jump in? I could talk forever, man. You got to jump in.
Yeah, I just heard open source, and I love open source projects, and you kind of touched on this already, Mario. But one of the questions that I had here is, can you share some examples on some of the open source initiatives that you guys are working on? I just love that space. I try to volunteer my time as much as I can to it.
I don't know if I'm involved in initiatives. I'm trying to stay ahead of the trends. Like I try to keep up with the trends. Like I think 5 years ago, you'd need to have your video pipelines up and running with like the industry standard frameworks. Like so for Linux, it's video for Linux, P4L2, and on the display side, it'd be DRM, KMS. But now there's a new open source stack coming out. So if you'd have this V4L2, essentially you would have a capture pipeline saying, okay, I've got my image sensor, it's got a driver. I have a CSI receiver, so that's like the MIPI interface. Then I've got all these blocks that are implementing my image processing pipeline. They would each have a driver. So they appear in the Linux world as these devices, these sub-devices that form a one big package. So it's still a little, we're at an industry standard, but you still have to control each of these little nodes to configure what we can call the camera. And so in the recent years, there's a new initiative, which is libcamera from, I believe the chief architect is Laurent Pinchard from the company Ideas on Board. And what they do is like they just wrap up all these components into one entity. And even beyond that, if you've got like an image capture piece of hardware that's doing this, and you've got a separate accelerator which is doing your image processing pipeline, these are like two completely different pieces of hardware, but they combine all this into one camera object. So they make configuring all these V4L2 devices much simpler and much accessible. So like I think the best example is the way that Raspberry Pi has configured all their cameras and their very complex ISPs under this lib camera tool, and it's very effective, and you can't ignore it. Like I think I bought a Raspberry Pi just to see what this thing was doing, and it really makes the experience to the user much more. It's much simpler to use. So that's what I'm trying to reproduce on our boards on the with an
And
FPGA based image processing pipeline. So kind of that's one part of it that maybe I'm giving back to the community of Skate. LibCamera does not yet support an FPGA-based capture pipeline, so that'll be my contribution.
I think that this is a great time to go into some of these projects that you build. That's you, right, Mario?
Yeah.
All right, so maybe you could talk a little bit about like what you're doing here. Like this is a project on Hackster.io, by the way, and we'll share these links if you want to. Here, let me put it right now in the chat. Well, maybe you can kind of like talk to us a little bit about what are you doing here? What was this built on? While I share the link.
Yeah, this turned out to be a journey. It's actually one of our application engineers asked me, "Hey, Mario, I need something that detects sign language because I want to use it to control this piece of hardware for a demo that I'm doing." Okay, so it sounds like a pretty simple request. So we started by just taking the images and create a classifier that would just detect the sign language, and that worked pretty well with like a given background. I used a training data set from Kaggle, which had a pretty blank background, and I tried it in my office, which normally is a white wall, and it would work really well. But then we would get at a demo environment where there's a lot of people walking around in the back, and then we noticed that it wasn't working very well. So then I realized that, well, Google have this MediaPipe framework, which includes like a hand detecting, which is very effective. It's very well done. So that was like the second attempt of getting sign languages done. So I said, okay, let's use MediaPipe. And this is an example of just, fleshing out which of these models will actually run on a given piece of hardware. These models run really, really fast on a modern computer, like hundreds, maybe thousands of frames per second. But if you go on embedded platforms, then it really slows down. Like you can lose like from 30 to 100 times the performance just because it's not the same hardware, not the same memory. So you want to investigate those models and accelerate them, because now the embedded hardware, they have specialized hardware for accelerating these models. So, but it becomes specific to each manufacturer. So we've been exploring, me and Monica, how we could accelerate these on our different boards. So yeah, I should be talking as you're scrolling through. This project is the overview of those models, which is pretty. They have some for hands, so they detect the palms, and give landmarks for the fingers. So the idea of going down this path is, which hasn't been done yet, is they actually give like a three-dimensional view of the hand. So there's like X, Y, and Z points. So if you think of it, they're actually giving a point cloud of your hand or your hands. And the idea would be to take that and detect the signs from those landmarks instead of just static images, which is what a classification model would do. So that's the next spoiler alert content to come out. But like every time you take the point, I guess, of this story is, as you take these industry standard models and you try to run them on your specialized piece of hardware, there's often a unfortunate surprise that, oh, I'm only getting a few frames per second. I'm sure anyone who's tried to develop embedded platforms knows what I'm talking about. And it's either the end of the road, or you got to start, okay, how could I accelerate this piece? Because I really want to use, I'm really happy with the quality of output that it's giving. And for neural network models or deep learning models, what usually happens if you try to deploy it to a specific manufacturer, they'll usually have their specific tool chain, and they'll support a various number of layers. Sometimes layers aren't supported. If you hit a layer that's not supported, what typically will happen is you circle back to your training phase, you modify the model, and you retrain. So, but in the case of these MediaPipe models, Google does not provide the training data. So you're on your own to recreate that training data or finding other ways of accelerating it. So anyway, these are all the points that we kind of touch on, and it's issues that we ran into that we just document. Sometimes there was no so elegant solution. Sometimes we did find something. So yeah, there's quite a long series of projects.
That's a robust guide slash, project there, Mario. I mean, I was scrolling and scrolling and scrolling. I was like, it's gonna get in, but I mean, you kind of summarize it here, right? This is a nice long project. I mean, it's a beginner project, but it's nice and long, and it looks very detailed. I'm pretty sure that anyone who would like to go check that out would have a lot of fun trying that out. Very cool. Monica, I think you have one too, right? Do you want to kind of break down yours as well? We have this optimizing ML on the MaaXBoard. MaaXBoard. How do you say it?
MaaXBoard, yeah.
MaaXBoard, okay.
Yeah. So I was just building on what Mario had done actually, which, yeah, it's like very robust and incredible. Like the GitHub repo, it's something that hadn't, so yeah, what Mario, like MediaPipe models were not open source. And so like just getting figuring out all of the landmarks and everything, and then Mario had to read a lot of documentation, I think. So anyways, it's so well explained. There's nothing else really like it. So I was able to build on it and run it on the MaaXBoard OSM93 because...
Can I answer a question? I'm so sorry for interrupting.
Oh, yeah.
This looks like, is that Raspberry Pi footprint?
It is, yeah.
It's the Raspberry Pi. Okay, yes. Awesome. Okay.
In fact, it's actually now the newest one has a black silk screen, so I need to replace that image. But yeah, it's Raspberry Pi.
Is one of these over here, maybe? We'll go to. Anyways, I didn't mean to interrupt. Sorry, I just wanted to make sure that I actually was seeing the Raspberry Pi footprint there. So yeah. Okay. Yeah, please.
Yeah. So this board has an AI accelerator NPU that is very low energy power efficient. And so there's a few things required to run a model on it. It's pretty easy, but I wanted to just show how to. First, you got to quantize your model because it can only run int8 or uint8 or int16. Models. So you have to quantize your model to bring down the bits. And then once that's done, you actually run it through this like model converter. And the model converter, you can do it really easily, really quickly with just one command, or you can get really in depth and optimize your model for whatever you're doing. So you can make it run just on the board's microcontroller, the Cortex M33, or you can have it run on just the A55 dual core CPU, or you can have it run all on the NPU. So there's lots of options. You can have it run in different parts. You can split it up. You can run multiple models and have them run on different cores. So there's lots of different options, and I wanted to at least get started with showing how to do that.
This is awesome. Yeah, highly recommend.
That is awesome.
Actually, I didn't see how cost effective it is. This is actually not bad for what you're getting there, right? I mean, it's about time, like people kind of, Raspberry Pi is amazing, right? But it's about time that, like some people maybe step away from the Raspberry Pi and go and explore some more robust hardware solutions, right? Eventually you get there. If you get into like, that space, you're definitely going to need to evolve past the your workloads will evolve past the demands of a Raspberry Pi. So that's great. Thank you. Let's get back to some more questions. Tory, I kind of took over for a minute, man.
That's perfect. Well, this has to do with, there's a lot of AI, especially going on right now, but what are there any trends that you would like to talk about that are going on right now? Maybe try to be like see the future a little bit, but what trends do you think that are going on right now that you're most intrigued by or that you're following that's going on?
I guess like what? Yeah, sorry. Like I want to kind of
trends.
Like customers, like what kind of customers are they getting, or what are customers are they expecting?
Sure. Yeah. Or what devices or what are people doing in this space that maybe they haven't been doing before that wasn't possible, but now that the technology is changing, what trends do you think will be going on in the future that will help me to kind of get an idea of what is achievable, I guess? Sorry.
The first thing that comes to mind for me is large language models. So there's small language models also. So anything less than like 1 billion parameters, I think, is a small language model. So there's things like Phi3, Llama, that you're able to actually run on some of these boards. And then the boards themselves are becoming more and more powerful. So like you say edge AI, and you mean something that's not super powerful, but now there's boards that have, 100 teraops per second. So there's some really powerful boards that can run really powerful models. So kind of those things converging makes it possible to run things like LLMs or
Awesome.
It kind of feels like we're starting to live in the future. Things are now possible that weren't possible before. I don't know how you guys feel, but now I almost overwhelmed. I want to make all the inventions because I want everything to have a small language or a large language model built into it.
Yeah, it's definitely hard to keep up, and I think you have to realize that it gets like the knowledge you need to understand all this. It's beyond one person. You just have to start thinking about a team. Like, okay, I can't touch on everything in depth. I could skim the surface on all these subjects, but it's quite overwhelming. One thing that really intrigues me now is the amount of resources that it takes to train these LLMs, and seeing how we're starting to see how people are starting to be able to train them with less of a ecological footprint, if we want. I think that's a big. I really hope that evolves to the point where it's almost been to the point that I still have a gasoline vehicle, and I don't feel as bad as I used to because I know how much pollution these LLMs are creating. It's just crazy. But I think there's pressure for that to evolve.
It makes me think of a quote from Michael Scott in The Office. Sorry, I'll pull your quote back. I'll pull your comment up here in a second, Constantinos. A quote from Michael Scott is diversity tomorrow because today is almost over. It's like basically invent tomorrow, because today's almost over. Anyways, silly, but that's what made me think of. Let's bring this comment up here from Constantinos and address it here. The trick is to make small SML behave like an LLM. SLM, I think that was the typo. The trick is to make small language models behave like large language models with appropriate fine tuning in some scenarios. Any takers? Anyone want to comment on that?
I think if I understand this correctly, I'm more involved in like the convolutional neural networks, so I'm effectively living in the past. But everything's relative. But I think what Konstantinos is saying is a lot of these models are like super generalized, right? Like even the image classification, detection, etc., all the way to the LLMs, like they can perform ideally in any environment. But if you're creating a product which has a controlled environment where you don't need that level of generality, then you could do like a kind of like a teacher-student model where you use a higher end model to train a simpler one that will be more compute effective in your scenario on the hardware that you have. So that's definitely something that we've been seeing in the convolutional neural network land, but it's the first time. I'm assuming this is what is meant here with LLMs as well, which is
exactly spot on. And we got another question here from Raul Vergara, awesome guy in the industry from Thistle, actually. And so, are these models and increased workloads at the edge increasing the need for security at the edge to be an absolute must? I like this question. I'm curious. I want to hear what you guys all think about this. Security at the edge, how important is it? Especially for these types of models, right?
Yeah. I mean, as more as you're using these models, I mean, a lot of people, I mean, I think it's always been an absolute must for most commercial products, but especially like people use, text to speech or whatever, you're saying things that you could be using it for very private use cases. So absolutely, and most of our boards have like come with some form of both hardware security and then yeah, so edge lock or something like that.
You giggle, Monica. I'm wondering if you thought like you had a flashback of some one of your friends getting hacked or something, some catastrophe.
I'm just thinking of the things that I use AI for, like interpreting my dreams. So yeah.
Nice. Anyone else want to comment on this one before we kind of move on?
Yeah, I think it's a good point. It's as we put these complex systems in place, like the most secure device I have is my lawnmower. I mean, no one could hack into that just because there's no way in. So as we get these products, our vehicles, everything that with all these communication, they become doors for vulnerabilities. So I think like the whole AI at the edge momentum is an effort to address that instead of communicating back and forth with some kind of server, which we're calling the cloud or a service or whatever. We try to bring those functionalities within the device, so that limits the communication to the external world, reduces some of the vulnerabilities. But I think maybe what Raul is saying is even despite that, if we're still communicating, there's still vulnerabilities. So yeah, security is definitely it's not my area of expertise. But yeah, I think we always have to, like, we've heard the story of someone hacking into a vehicle and applying the brakes. Like I don't ever want that to happen to me.
No.
But that just shows how far it can go.
Yeah, no, absolutely. Raul actually does focus on security. That he works for a company called Thistle.tech, and they do security infrastructure for like edge devices and lifecycle management of that kind of that area. And I actually plan on exploring that a bit, right? So like I'm pretty interested in that kind of stuff right now. So I'm pretty glad he came in and brought this question up. Let's move on. Sorry, Tory, go ahead.
Oh, what I was going to say is there's a lot of regulatory environments which you have to worry about security, and I think it's kind of like a double-edged sword. I do appreciate the fellow nerds that actually focus on security because I do think it's important. But yeah, you have to always be hyper vigilant, and I guess the mantra is risk mitigation, right? So as much risk as you can mitigate as possible, the better. But yeah, it's a never-ending task.
Yeah, if there's what is it? What didn't like someone need? Didn't like the FBI need access to like an iPhone or something like that? Yeah. And so then like this whole government thing, they're talking about we need to get a backdoor into like Apple devices and all these devices. Like, well, if you put a backdoor, then someone's gonna figure out how to get in there, right?
Mm-hmm.
So
this is how. Yeah, it's happened. In the 90s too, there was talk about that, some kind of chip the government wanted to put in it that literally just broke encryption, so that way everything is unencrypted. But yeah, that's the problem is if there's a backdoor for one person, it exists for everyone, right? That's just the nature of things that are connected to the internet.
So we talked about this in the green room before the show. I just want to kind of like put it out into the open because it's a question that I like to talk about is just developer communities, right? Tria exists. You have a lot of cool stuff going on. You interact with developers in some way, shape, or form through the efforts and the initiatives in the open source space. And I asked before, I was like, I might ask you this question, but I don't want it to be a gotcha. Like, where do your developers hang out? And then like, boom, like obviously Hackster.io, right? Like it's kind of like all part of this. And so Monica and Mario, you both brought up sharing your Hackster.io profiles. Do you mind like posting those in the chat or something at some point, or maybe sharing them with us so we can get people to go? If you want to go interact with these folks later on after the show, you want to like get more involved with Tria and the cool stuff that developers are doing. Monica and Mario both have Hackster.io profiles. Actually, I have your profiles right here because we were just looking at your projects, right? I can post them.
Yeah, absolutely, Robert. You can share those.
Awesome. And does Tria have a Hackster.io like community page or not yet?
There's an Avnet boards page, so it's not called Tria yet. Actually, thanks for reminding me. That should probably be changed. But if you go to Hackster.io/Avnet, you'll see our developer kits there.
Oh, nice. Okay, perfect. So I'll share that as well. Perfect. Some nice developer kits. Yeah, very, very, very cool. Tory, you still have some more questions here. You want to pop one more off here?
Sure. Yeah. Well, once everything right now on my mind is mostly AI and edge computing. We've talked about that a little bit, but how is Tria actually positioned to contribute in this space? You've already talked a little bit about it, but I don't know if there's anything else that you'd want to share. And we also talked about in the green room how difficult it is to actually navigate this space because a single individual can't hold all of this information in their mind. So I almost need my hand held as I'm traversing this space. But
Who's taking it?
So in terms of, well, I think in terms of, sorry, I was thinking in my own head. It was about open source, right, Tory?
sure. And what Tria is actually kind of positioning, how they're positioned to contribute.
I don't think it has to be open source, right? Like you could be like, I
Yeah.
mean, you could contribute to that space without, making it open source by providing an awesome product for either some B2B relationship or your B2C.
Yeah,
Exactly.
I think the thing is, like, especially when you're providing hardware board, it's just making sure that you support these infrastructures that everyone is using. Like, I think there's two main ones that come out in my mind is GStreamer, and then there's the ROS2. So if you're doing like complex multimedia pipelines, that's usually GStreamer. Although both can be integrated into the other, so it's not a clear-cut one or the other solution. You can actually have both running on the same system, but like the essence of the system will either be on one or the other. If you're into more like robotics applications, that's the ROS2, so robot operating system. It's actually not a operating system; it's a meta operating system. So it sits on top of Linux. And GStreamer is a plugin that also is supported by um, a lot of manufacturers. And today, what we see is almost every hardware manufacturer will have its specific plugins for its accelerators and hardware. So I think the next move will be there'll be a unifying set of plugins to support all these hardware manufacturers. So if you're switching from one manufacturer to the other, you don't have to change your entire GStreamer pipeline. It'll be, and this is where the NN streamer comes in. I don't know if Monica, do you want to talk about that one?
Sure, yeah. So one of the things, NN Streamer is a plugin for GStreamer that supports tensors. So you can do like inference using NN Streamer. You can just take your model, run it through NN Streamer, and you can actually take the parts like the tensors. So you can do things like resizing, like the camera pipeline part of your AI workflow you can do using NN Streamer. And it's nice actually with NXP, they've actually enabled it to run on their NPU, so that usually you have to do this kind of like the image resizing and stuff outside of the NPU on a lot of boards, but this lets you actually accelerate that as well. So that's a really cool software, and it's a great thing to have enabled. I guess also as far as like enabling machine learning, you have to run like the big inference engines. So that's not a given always. So making sure that those run, like, TensorFlow, whatever inference engine you need. And then OpenCV also, which is like, does the same things as NN Streamer does, is pretty important to have in your out-of-the-box Yocto image. So we include those things as well.
Just give a little more depth on that subject for the GStreamer. As an example, NVIDIA have like there's series of plugins called DeepStream. AMD Xilinx will have their set of GStreamer plugins called VBAS, so Vitis Video Analytics SDK. And another company, Halo, they have their set of GStreamer plugins. It's called Tapas. And they're essentially all doing the same thing. Like they got like a complex pipeline, which usually has some pre-processing, image resizing, color format conversion. Then the neural network or the model, maybe a transformer, a vision transformer that's being run on accelerated hardware. And then some post-processing. And for some of the models, the post-processing is pretty significant. One of the examples that comes up the most often is the YOLO object detection models. Well, it's one thing to accelerate the bulk of the model to accelerated hardware, but there's this very complex post-processing that has to be run, and that often ends up on the CPU. And what's unfortunate is for each of these manufacturers, they're all reproducing the same code just to work with their plugins. So what I hope to see, and that's why we're interested in NN Streamer is that like those specific parts that are running on a CPU, but they're essentially, it's all the same post-processing functions, regardless of where the essence of the model is being accelerated. It should be the same code for everyone. So I think that'll be the next wave for making just integrating AI models on this variety of hardware with different accelerated hardware, more easy to use. I think that would be that's the next evolution that we're expecting to see.
Tory, follow up, or can I ask something?
Yeah, go right ahead.
Okay, I want to share my screen here one more time, and I want to ask about this board because I'm just a huge fan of Qualcomm, and I'm a huge fan of Snapdragon stuff. It's kind of like my upbringing in terms of like some of the first stuff that I worked with is the Dragon Board 410C from 96 boards. This board, the QCS or Qualcomm Vision Kit, right? The Qualcomm AI Vision Kit. Can I ask like any spoilers, any teasers? You guys building anything cool with this board? Something we can look forward to? And maybe also without me spending some time, because I have not yet, right? I only just heard about, you only just kind of pointed this out. I'm very well aware of the RB3 Gen 2 kits, like those robotics kits that Qualcomm makes. I have not seen this board yet. So like, I'm wondering, you know, why might I get this board? What are some specs that make this board special?
Yeah, so it says right at the top, 12 tops. So it's pretty impressive. Compute power, 8 cores, 4, and you can use 4 cameras. So you can do 4 media cameras.
Oh,
yeah. So it's really designed for vision. And then Qualcomm has been really awesome about making a lot of different models available on their, they have like the Qualcomm AI Hub where they have kind of a model zoo there for each of their boards. So there's lots of
already. Have you played with the Qualcomm AI Hub?
Yes. Yep. Yeah.
Awesome. Okay, cool.
Yeah. So there's lots of different models, vision models, especially you can do everything from, classification to image segmentation. They have models like YOLO, V6, 7. Anyways, they have a lot of different newer models there. It's got some great AI processing.
When can I get one? 16 weeks? That's a long time.
So right now there's still, I guess the hardware itself is not officially launched for developers. So I think it's
that's how special it is, right? That's how special it is.
Exactly.
But you have one on your desk, right? Like that you can hold up to the camera? No, not yet.
Unfortunately, I don't have one on my desk. My colleague has another kit, so yeah, I don't have one, unfortunately.
Very cool.
It's hard. They're hard to get. Yeah.
I mean, like these types of boards, right? They're I don't want to say niche, right? But like by the time you get to these types of needs, like when you're actually developing a product that requires this kind of stuff, you're not selling them in volumes like Raspberry Pi, right? And so like the lead times they increase that way. Like it's just what it is. It's just the market. We have some questions. Do you mind if we dive into some community questions here? And thank you, by the way, for everything so far. I got to thank you every now and then throughout the episode, right? So let's see. I'm going to bring up one from Konstantinos again. What's your experience with embedded MPUs? Are they uniform enough, or do you have to essentially develop for each one separately? I really like this one.
Yeah. I would say a good metaphor is like, it's like a language. Like the more, they're all different, but the more you do, the easier it gets.
Konstantinos clarified here. He says across different vendors.
Yeah.
Right?
So I worked with ones from Qualcomm, NXP, Renesas, and they're all, and NXP has multiple different. They're all a little bit different. Some of them are easier to work with than others. I've found out a lot of them support the same things. I didn't even mention like Edge Impulse, for instance. A lot of that's one of the projects that we've given a lot of time to supporting on some of our boards. Or like TVM is another software that you can use to develop for many different, that is supported to, it's a model compiler basically. So you can compile your boards using the software to run on the NPU in an optimized way. So there's like tools that work across different NPUs. That makes things a little bit easier, but they all have their own quirks.
I could imagine every vendor, like, you know, has their own kind of developer environment. In some ways they have their own developer tools. They have their, so like, you know, it's funny because like, it's not a silly question. It's a good question, but like someone came into the ARM developer server and asked like, hey, I'm new to ARM. I don't know anything. Where do I begin? Right. And then like, go to Google and search, I'm new to ARM and I want to begin. Right. And you get a bunch of stuff. But the problem is that like the question, while it sounds silly, it is very real, because when you want to get into ARM, you go search this and you end up with like, well, I'm building on the STM32. Well, I'm building on this. And it is still quite fragmented enough to where you kind of do have to give some guidance for people who want to get into the space. And now you talk about NPUs, right? And that's just this next level of somewhat fragmented guidance, right? So yeah, there is a follow-up on this question, and I do want to address this. I want to give everyone a chance to like have some more time here. One more question from the audience. Is that okay, Tory, or do you want to?
Yes, that's more than fine.
Yeah. All right, let's do the follow-up from Konstantinos. It's a follow-up to the same question you already asked. How does NPU utilization compared to CPU SIMD optimization? Is there a point anymore to using SIMD for AI ML stuff where there is an NPU available?
I would go with an NPU if there's an NPU available, just because that's what it's built for. Obviously some of the NPUs are built for specific tasks, like, you know, only support CNNs or only support, recurrent neural networks. So it's, I would say NPU is generally the way to go. Just because that's what it's designed for, and that's what there's software that exists to make it even more optimized. So
I think that easier. I could take that in the other direction. I think the first thing to try is maybe what's already available in the processor. If there's accelerated libraries with that, if that gets the performance you need, and then if not, then it's definitely worth going to the specialized deep learning units or whatever they're called, DPU, NPU. Every vendor has a different name.
Is a lot of the NPUs are like, a lot of the boards with NPUs are as cheap as the boards with CPUs, so it's not a huge price jump. Yeah,
starting to be industry standard now.
I mean, chalk it up to like basically what NPU you're using, maybe what that developer experience is, what CPU you're using. Like, I mean, in some ways, like you might end up spending way more time trying to achieve what you're trying to achieve SIMD on CPU versus using the NPU. I don't know. There's lots of trade-offs, right? Eventually, maybe Konstantinos, you can go write a comparison benchmarking article and show the developer experience in that fork in the road, and post it on Hackster, leveraging Tria. I don't know. There's lots of leveraging some Tria hardware. But yeah, very good questions. Time flies. Top of the hour, right? I mean, what's left? Tory, did you have any more questions? Because if not, we're going to start winding this down.
Yeah, well, I think we should, because I think there's a couple more things that we want to interject in here as we wind down, just to make sure that we were able to showcase everything that we want to this episode.
Yeah, Tory, I think we should get like a little shameless plug thing for my stream deck that I can hit. So it's like shameless plug time, boom, and like something silly pops up, and then they know it's time for their shameless plug. You earned it.
I can design you one.
55 minutes listening to us babble and ask you a bunch of questions, and you made it to the end. It's time for a shameless plug. Is there anything, I know I kind of stole some of your shameless plugs and talked about them throughout the episode, but is there anything that you would like to plug specifically as we wind down and get to the end of this episode? Both of you.
We talked about, I guess, yeah, you go ahead.
Go ahead, Monica. Okay, I was going to say, well, if you want to check out the hardware that we offer, that would be the Tria Technologies website. And if you want to just, if any of the projects we mentioned interest you, maybe check out our Monica or my Hackster profiles. That's where we post our projects.
I have the Tria Technologies website up right here. So the products you said, go and check out Tria Technologies here.
Yeah.
Where would be your shameless plug? You're saying like, where should they go first? What's your favorite spot on the website? Is in these products area? Go check all these out.
Well, I basically live in the application specific SLMs for those Xilinx boards, but then where would the Qualcomm board be, Monica?
Under development kits.
Okay, so we have single board computers, development kits. All right, here, yeah. So you can go into the development kits here, check out all the different development kits. Oh, this is pretty cool.
Oh, yeah.
Yeah, I was saying, like, when I landed on Tria, I was impressed. There's just like, you guys are doing a whole bunch. You have a whole lot of things there to explore. Wow. And it is actually really cool when you start to think about like the entity that is Avnet, Tria, Hackster. Like it's pretty rad. Here's the Qualcomm board right here.
Nice ecosystem, yeah.
Yeah, very nice ecosystem. Yeah, very cool. All right, so that's your shameless plug, Mario. We got people going over to Tria Technologies or tria-technologies.com. I'm going to share this right here, and you can go check out the development kits area. Monica, did you want to plug anything, or did you kind of share the same plug with Mario?
I guess my quick plug is we'll be at Embedded World in Germany in March 11th. I won't be there, but we have our boards there, a bunch of demos. So, yeah.
You need someone to like walk around with you and carry your backpack?
I don't, but I'll ask Peter and Jim that are going from our team. So
okay, cool. Yeah, I'm really good at that. I'll carry a backpack all over the conference hall for you. You get to where you need to go real quick without having, not getting tired.
That's really
I'll even say some jokes along the way. Yeah. Okay, cool. That's great. I want to just thank both of you, Tory. I mean,
yes, thank you guys.
Yeah.
Yeah, thank you both for the nice format. It's really enjoyable.
Yeah, thank you.
Hope you had fun.
Cool.
So then, if you don't mind, Tory, if it's okay with you, kind sir, Monica and Mario, I'm going to kind of like close this out and say goodbye to everyone. Is that okay?
Yep.
Okay.
Sure.
Awesome. Perfect. Well, yeah, on behalf of DevEco, on behalf of Hackster and Avnet and Tria, thank you so much, everyone, for joining us, spending this hour with us and asking amazing questions. And we really hope that we were able to provide some value to you. If you have any feedback, if you have any things you'd like to see on Proception live streams going forward, toss something in the comments. Reach out to Monica and Mario on their Hackster profiles. Get in touch. We'd be happy to try and figure out how we can feature some of these cool things that you developers are looking forward to seeing. Very grateful to have you here. Mario, Monica, very grateful to have you here. And thank you so much for taking the time. We really appreciate that. Tory, last remarks before we kind of like all wave. You want to say goodbye?
I think this is exciting, and I'm just excited about this episode and to see you guys again. So till next time.
Perfect. Everyone have a good one. Thank you so much. Take care, everyone. Bye. We'll see you next month for the next Proception Live. Stay tuned. Keep in touch, and we'll make sure that you get that information out there. All right. Bye.